All right, so you have your bell ringer done, you've got your guided notes pulled up, and you are ready to rock and roll. So, what are we going to talk about today? Today, I can evaluate the chemical and physical processes involved in the formation of soils. That's right, we're going to talk about dirt. Doesn't get more exciting than that. It's not going to be that bad. We're only going to talk about soil for today and tomorrow. So if you're already like, I'm out, just hang with me. We're going to learn some important stuff about it because soil is actually very important. Believe it or not, it's true. So what even is soil? Let's define it. So soil is the loose mixture of small rock fragments, we know what rocks are, organic matter, we don't know that yet, but we're about to, water, know it, and air, know it. Now, what makes the soil so special is that it can support vegetation, and that's just a very fancy way of saying plants. So when you put plants in soil, depending on the plant, it can grow and grow and grow. So that is why soil is so important, because you wouldn't have any food without soil because you got to grow it somewhere. So that's why we got to know about it. Now, we talked about organic matter right there. What that sounds pretty fancy too. What is that? So organic matter is just the remains or something left behind of something that was at one point alive. So this could be, when I say animal remains, that means it can be like an actual dead animal. So if an animal dies and sits on top of the soil, it over time will become part of the soil, kind of freaky. It can be dead leaves after they fall off the tree and lie there and on top of the soil for a while. It can be wood shavings or manure or poop. So all of those things are added into the soil either naturally or by people themselves. We can make really good soil to make it really good and help it support all of that vegetation. Now, how do things become organic matter? Because like at one point you're alive, like I'm alive, and then you die, or an animal's alive and then it dies, but how does it become part of the soil? What is that about? So it has to go through this process called decomposition, which also sounds super fancy, but there's a lot of different things that have to go through over time, usually heat and pressure. Things bury on top of that dead living thing, and then eventually it becomes organic matter, so it becomes part of the soil. We don't have to know a whole lot about the decomposition process, and that's really all you got to know about it. So don't worry about it too much. You've got a living thing or remains of a living thing. It dies, it gets buried, it goes through decomposition, and becomes organic matter, which becomes part of the soil, along with the rock fragments and water and air. So most soil is organized in a certain order. So up here is the top of the earth, where things are living, things are growing, we're walking, and then as you dig down, you get different layers. Now, I know we've already looked and chopped up layers of the earth. That was a much bigger picture. So when we were talking about the layers of the earth, we had the crust, we had the mantle, we had the core, and we dug all the way down. Here, we're only talking about the very top part of the crust. So we're digging into the earth, but not very far, okay? So let's label what these layers are going to be called, and beside it I have the definition or what is actually going on in that specific layer. So this very top layer here we call humus. Now humus is just another fancy way of saying organic matter. So this is where all of those living things are going to be. You see all those dead leaves, maybe some manure, maybe a dead squirrel, I don't know. That's where the organic matter is going to be. Now, right below that layer, when you hit the actual, what you probably think of when you think of soil, that is called topsoil, which is conveniently named because it's at the top. Now, this is where all of the nutrients, for the most part, most of the nutrients for a plant are going to be found. So, like if you ever buy a house plant or if you make your own garden in the backyard, often you're going to be buying topsoil because it has a lot of nutrients. So, it's nice and good and yummy for that plant to grow and be what it's supposed to be. Now, right below the topsoil, and you'll see that's where a lot of the ends of the plant tend to be. This is where it really hits its end. This is where you get all of those roots. That is going to be the subsoil. And it's called the subsoil because it is below the topsoil. Pretty easy. So this layer is going to be made up mostly of like sand, silt, clay, thicker particles of dirt, if you will, that hasn't really broken up in the way that topsoil is broken up. So it's a little bit thicker almost. Now below the subsoil, you aren't going to get much plant action down there. There's not going to be much happening down here. This is going to mostly be rock fragments, if I could spell. Rock fragments. So here in this layer, like it says, it's just going to be small fragments of rock. So you've got some of that sand, silt, clay, some of that dirt hanging out, but mostly you have bigger chunks of rock that haven't completely worn down like they have up here in the subsoil or the topsoil. So like I said, you're not going to get much growing down here. And below that, the bottom layer, you are going to get that bedrock. Not the Young Money song, but maybe you're too young for that reference. But the bedrock is where there's really no dirt. It's just solid rock. Just solid rock. So this is where the soil really ends. So over time, this bedrock pretty much breaks up into smaller rocks, which makes the rock fragments, and then those get broken up again into the subsoil. So really over time, the rock that you see here is going to slowly and slowly get broken up and broken up and broken up until it's teeny tiny and is more useful up in that top soil. Now, why on earth can't plants survive down here in the rocks? Why do they need that clay, that sand, that silt? Why do they need all that soil? Why can't they just grow through a rock? So, this part is super, super important. You've probably never thought about this, but different types of, or we'll say different particles, are not all the same size. So if you think of gravel's pretty big, and sand and silt and clay, they're actually, when they're in their smallest form, they're different sizes. So whenever you put those particles together in one layer, like if you look over here at the right, if we put a bunch of sand together in a layer and a bunch of clay together in a layer, they aren't necessarily going to completely fill in every gap. What do I mean by that? So if you look at the sand, see how when you put sand together, there seems to be some open spaces because they don't all fit together beautifully. There's these little small holes. Clay also have some small holes, but they're very, very teeny tiny. Those open gaps in a chunk of sand or a chunk of clay or silt, we call those pores. You may have heard about pores like in your skin or on your face, and that's where acne builds up. Sorry, kind of gross. But that's the same thing. It's like a hole, so it's able to have things pass through it. So these pores are super important because without pores, you wouldn't get any water going through here. If there was no open spaces here in the sand, there'd be no water passing through. So, like if you think about this topsoil and the subsoil, it has that sand, silt, and clay, but since there's pores there, water is able to pass through, so water can get down to those roots so those plants can grow. So again, because we have that sand, silt, and the clay down there, water can get through so it can support a plant. Down here, these rock fragments, they don't really have as many pores because it's solid rock. So not much water can get down there. So the roots don't grow down there. It makes sense, right? Now, this part's pretty important too. Like I said, the gravel's the biggest. Sand is going to be the next biggest. This is obviously not actual size. Sand is not that big. You know how big sand is. Below sand, the next smallest is going to be silt. I think that's really what we think about when we think of dirt. That's what silt is. And the teeny tiniest, smallest particle ever is clay. So the larger the particle size, so in this case gravel is going to be the largest, the larger the porosity, which is just a fancy way of saying the size of the pore or the size of the hole in that chunk of sand or clay or silt. So the bigger the particle, the more porosity and the more water can flow through it. Pretty neat. Okay, now these last two slides, they're kind of related. We talked about what the heck is soil, what are the layers of soil, why does porosity matter, so how does it even get created? So we talked about weathering before. We know that weathering is just the breaking down of rock. And again, we talked about how there's rock up here that slowly gets broken down and broken down and broken down. Now there are two types of weathering, or ways these rocks can get broken up. And that is what we're going to talk about. So how do these big rocks break down and eventually morph into those small rock fragments that are used in soil? So there are two different types of weathering. Like I said, the first one we're going to talk about, I think it's the easiest one, is called mechanical weathering, or you might hear it called physical weathering. So this is just when physical processes, which we're about to talk about, just naturally break rocks down into smaller pieces. So the rocks themselves aren't necessarily changing other than the fact that they're getting smaller. So whatever is making up that rock, not changing, it's staying the same, it's still that rock, but it's teeny, teeny, tiny. Okay, so what the heck am I talking about? How does this happen? So there are here's some four really good examples. You can think of ice wedging. So what this means is if there is like a crack in a rock, and like this video shows, it fills with water, and then suddenly it gets cold enough where it freezes, that ice can expand and break off part of the rock. This is actually how a lot of potholes in the road form, because you have those cracks in the road already, and if it rains and then freezes, that ice will expand and cause the road to break up. So that is an example of mechanical. Another one very similar is called abrasion. So this is when usually the wind will sweep up teenier pieces of rock and it pounds this big rock and breaks it down until it breaks off as well. So it's getting hit by different particles or clay, sand, silt, whatever, until it breaks down into tinier rock. These two down here I think are the easiest. You think of a plant. If you have a very, very strong plant, and I know I talked about how over here the roots can't really go through rock too much, but if you have a really, really strong tree, sometimes it can have roots that are strong enough where it will grow alongside a rock or grow sometimes down into cracks in a rock. And since those roots are so big and so strong, it actually breaks up those rocks. And the last one, if you think about animals, especially think about a groundhog. I know we've seen them. If they dig through your backyard, they create holes in the soil, they create tunnels underneath the ground, and that obviously shifts some things around, and it can break up the rocks and the soil as well. So that's mechanical or physical weathering if it's only breaking the rocks down into smaller pieces. The last one, or the other type of weathering, is called chemical weathering. Now, hear me out right here. This is where it gets a little tricky. It is chemical weathering if the materials that are actually making up the rock, or the substances that are bonded together to form that rock, if they are changed into something new. So with mechanical, they're just getting smaller. With chemical, they're actually changing into something new. Kind of freaky, right? So how this is going to happen is we've got one of two examples here. First, a change in pH. Now you may have heard of pH before, you may not have. I'm honestly not sure if you have. But basically this is just a fancy way of saying that an acid has been added to the rock and it changes the pH. The pH is just a number, 0 through 14, that measures how acidic something is, or how much acid is in something. So if it has a low number, it's super acidic, it has a lot of acid. If it's a high number, it's basic and it doesn't have much acid at all. So if you add acid to a rock, you can change its pH, and that's going to change the materials that make up the rock. So that is going to be chemical. I know you're like, you just busted my brain with that one. I don't fully get it. That's all you really got to know about pH. You don't have to know that much. Just know that an acid was added and it changed the rock. You're probably thinking, how is somebody going outside and just pouring acid on rock? Like that doesn't happen a lot. There's actually a lot of acid in some rain. So if there is a lot of rain, it can change the acidity, or the pH, change how much acid is on that rock, which can change the material of the rock. Freaky, I know. Now the other type I want to talk about is oxidation. Sounds fancy and sounds chemical. So oxidation is kind of similar to the change in the pH or adding an acid. The oxygen in the air can actually react with the other elements that are in rocks or soil and over time change how they look. Again, super freaky. I know you don't have to know too many details about that. Just know that there are elements that make up the rocks and there are elements in the air, and that oxygen in the air can react with the rocks and cause them to change. The best way to know that chemical weathering has happened is if you have a change of color. So like if you look at these rocks, they didn't start out that beautiful, beautiful burnt orange. They were probably like a dark brown or a gray, and over time it went through all that oxidation, all of that chemical weathering, and it changed the color. It kind of looks rusty. You've probably seen oxidation happen on a lot of old cars. If you ever see these like spots on a car on the paint job, that's because the paint over time has been reacting with the oxygen. It's been going through that oxidation and it causes it to change color. So just think about that. That's your chemical weathering happening right there on a car. Okay, I threw a lot of weird stuff at us just now. A lot of random things we have to know about soil, but just know, what is soil? Know the layers of soil, pretty easy. You need to know the porosity or how big a pore size is for different particles. And again, here's this little chart to help you. And the two different types of weathering. Mechanical, meaning it just breaks things down into smaller pieces. And chemical, meaning you're totally changing what makes up the rock. Okay, let's rest our little brains. I'll see you tomorrow and we'll get some practice with this. And then we'll move on to something else.